This is 2012 free response question number 2, still on part A, now a second method, method 2, with respect to y. So now we're going to look at a second method to do this that is probably going to be shorter if we're good at integrating with respect to y, because when we integrated with respect to x, this figure is complex with respect to x. It's made up of two distinct regions. But if I integrate it with respect to y, then it's a simple region. It just goes from my curve on the right to my curve on the left, and those two curves define the entire region. So some things that I will have to do a little bit differently. One is that I will have to solve this equation for x. That's easy to do if you understand logarithms, that if y equals ln of x, then x equals e to the y. You'll also have to solve this one for x instead of y, and since y equals 5 minus x, it follows that x equals 5 minus y, just solving that equation for x instead of y. Then the other thing that we'll need is, since the integration is proceeding with respect to y, so we're going to have our elemental areas going this way, we need to know the y coordinate where these points intersect instead of the x coordinate. Then I could really just go ahead and write a rudimentary integral, which is that the area is equal to the integral from 0, let's call this b now, the integral from 0 to b, and I'm going to do the right curve minus the left curve. So it will be 5 minus y, minus my right curve, my left curve, which is e to the y, and that's with respect to y. So now I just need to find this point, and that's not too hard. In fact, I've already done most of the work. Here's my work from method 1 when I did it in with respect to x. And if we go back and look at our graph, here's our graph that's sort of vertically stretched version of this graph. And I had already calculated the intersection point, but let's be fair and start over. We're going to calc the intersect. And it again asks us our first curve and our second curve. Well, sure, that's my first curve, and sure, that's my second curve, and that looks like about my intersection. Now, we know that it gives us the x-coordinate 3.693. It also gives us the y-coordinate 1.306. So we now know that the b that I have up here is 1.30, well, I could use 307. It'll be a little more accurate. Now, I can retype this number 1.307 into my integral, but I also can, again, take advantage of the fact that this y is a register in my calculator. So if I just use alpha y, that's a variable that has stored this number out to about 20 decimal places. So I can now go ahead and just set up this integral by doing math 9. Oops, I will probably need to escape from the graphing window first. So we're going to do the integral, that's math 9, from 0, and in the top here, we'll do alpha y. And that's going to be the y-coordinate from our graph. Now we're going to put in this, 5 minus y. Now we could use alpha y here, but as far as the calculator is concerned, it doesn't matter what variable we're using to integrate as long as this variable matches this variable. So I'm going to go ahead and switch back to x for my integrand, and then minus e to the power of x. So now I've got my 5 minus x minus e to the x dx. And if I do that integral, it's also 2.985. And they both seem to be equally accurate. So this integral simply comes out to be 2.986 once again. And now I've solved the problem with just one integral instead of using two integrals. So that's method 2, integrating with respect to y instead of integrating with respect to x.